Hi guys, Audrey here. Let's row reduce. Okay, so we have a system of equations and we have three questions. The first question is, how do the three planes intersect? Solved by row reduction. So I know that these are three planes because each of these equations has three variables. So I have three equations, that means three linear objects, and three variables, so that makes these things planes. So I've got three planes, and I want to know how they intersect. So we know that we do this by row reduction. It's asked to do by row reduction. So I'm going to stick it in a matrix, and we're just going to row reduce. So I have my coefficients there, and then 1, 1, 1 off on the side. Now, with row reduction, remember there are a million different ways that you can do it. I find that it's often easiest if we try to avoid fractions, especially because largely I'm doing this in my head, so that makes it easier for me. But even if you have a calculator, it's just easier to plug things in if you're dealing with whole numbers and not fractions. So what I'm going to do in my first column, remember we always start at the left and move from the left column to the right, I want to pick a pivot. Well, I have 3, 2, or 4 that I could pick from, and none of those is 1. 1 is a great pivot. So are numbers that are factors of all the other numbers in the column. 2 is not a factor of both 3 and 4. 3 is not a factor of 2 and 4. 4 is not a factor of 2 and 3. So we're going to make a 1. And we're going to make a 1 by doing row 1 minus row 2. So 3 minus 2 gives me 1. So I'm creating my pivot of 1. So I have row 1 minus row 2. Now this is telling me that row 1 is the row that's changing, and row 2 is the row that I'm using to change. So the only row that's going to be changing here is row 1. So I can just go ahead and write row 2 and row 3 because I'm not doing anything there. Now I've made my 1 here. There's a 0 in the row I'm using here, so that just stays the same. I think about it this way as well. 1 minus 0 is 0. 2 minus 9 is negative 7, and then I'm doing 1 minus 1, which gives me a 0 there. Now, I made that 1 on purpose to be my pivot. So that's my pivot, and I'm going to use it to make zeros in the column. So I'll do row 2 minus 2 row 1, and row 3 minus 4 row 1. My purpose being to make that 2 a 0 and make that 4 a 0. 2 minus 2 is 0. 4 minus 4 is 0. So that's where these row operations came from. So in other words, I'm saying 2 minus question mark times 1 is equal to 0. Well, that has to be a 2. So that gives me row 2 minus 2 times row 1. And then 4 minus question mark times 1 is equal to 0. Well, that has to be a 4. So this gives me row 2 minus 4 row 1. All right, so now I have made zeros on purpose. I am not changing my first row. I just wrote an extra 1 there. 1, 1, negative 7, 0. So then I'm doing 0 minus 2 times 1, that gives me a negative 2. 9 minus 2 times negative 7, that gives me a positive 23. So that's 9 plus 14, and then 1 minus 2 times 0. Then 6 minus 4, that gives me a 2. Negative 3 minus 4 times 7, that's negative 3 plus 28, that gives me a 25. And then 1 minus 4 times 0. No change there. Okay, so now I'm moving on to my second column. I'm done with my first column, so I'm going to move on to my second column. And in my second column, I want to pick a pivot. Well, in this case, the only numbers that I possibly could pick as my pivot are the negative 2 or the 2. So those are also the only numbers that I can use to make a 1. Well, negative 2 plus 2 is 0, so I can't make a 1 that way. And multiplying by a half gives me fractions. So I'm just going to go ahead and pick this negative 2 as my pivot. And for the moment, I'm going to leave it a negative 2. I'm not going to make it a 1, because as I just said, negative 2 plus 2 is 0. So I can easily make a 0 below my 2. So then this will be row 3 plus row 2. And where did that come from? Where did that row 3 plus row 2 come from? 2 plus what equals 0? -2. We already have a -2 there. So then this will be 1, 1, -7, 0. I'm not changing this. 0, -2, 23, 1. And then I will have 0, 0. 25 plus 23 gives me 48. And then 1 plus 1 gives me a 2. Okay, so now at this point, I'm going to make that -2, which is still my pivot. I'm going to make it a 1 to make zeros above. So notice I was able to make zeros below before I turned it into 1, and that's totally fine. I don't have to do all of my moves at the same time. So this, we will do row 2 times -1/2, which will give me 1, 0, 0, 1, 1, 0, -7, 0, 20, -23 over 2, and -1 over 2. Which then gives me a 48 and a 2 down here. So now I'm going to do row 1 minus row 2. Minus row 2, again, my goal being to make that 1 up top a 0. So I'm going to end up with 1, 0, 0, 0, 1, 0. And then here I will have -7 minus 23 over 2. So that's minus -23 over 2. That's plus 23 over 2. That's going to give me a 9 over 2. And then 0 minus -1/2 gives me a 1/2. And then that doesn't change. So we have a -23 over 2 there. And a -1/2 here. And then we still have that 48 and that 2. Well, at this point, we now are in our last column. The only value we can pick as our pivot is 48. We have no choice. Making 9 over 2 and -23 over 2 0 with 48 is not really all that easy. So I'm going to go ahead and straight up make that 48 a 1 by multiplying row 3 times 1 over 48. Which will give me here 1, 0, 0, 0, 1, 0, 9 over 2, -23 over 2, 1, 1 over 24, -1/2, and +1/2. Okay, now my last step is to make everything else in that column 0. Now that my pivot is a 1, that's pretty straightforward. So I can do row 1 minus 9 over 2 row 3, and row 2 plus 23 over 2 row 3. And I only have 2 calculations that I actually have to make because columns 1 and 2 aren't changing. The rows, there's a 0 in the pivot row, so there's no change there. I've specifically made zeros here. That 1 over 24 is not changing. So then I'm doing -1/2, or I'm sorry, +1/2, row 1 minus 9 over 2, 1, 3. So that's +1/2 minus 9 over 2 times 1 over 24. And that is going to give me 5 over 16. And then I'm doing -1/2 plus 23 over 2 times 1 over 24. And that is going to give me -1 over 48 for my final answer. So my final answer is not the matrix. It's not this. The question was, how do the 3 planes intersect? Show by row reduction. So the answer is that here x is equal to 5 over 16, y is equal to -1 over 48, and z is equal to 1 over 24. So the 3 planes intersect at that point, at the point 5 over 16, -1 over 48, and 1 over 24. And that is my final answer to question 1. There is one solution. That solution is that point. Question 2. Is the coefficient matrix A invertible. There's no need to find A inverse. Well, we actually already have the answer to that. We can think about this in two different ways. So first, let's remind ourselves that the coefficient matrix is just the matrix of coefficients from this. So my A here is 3, 1, 2, 2, 0, 9, 4, 6, 3. So A is equal to 3, 1, 2, 4, 0, 2, 0, 9, my bad, 2, 0, 9, 4, 6, negative 3. And let me just double check I got that right. Yeah. And yes, it is invertible. One, because when we just did the row reduction, it reduced to I. And we know that reduction to I is the thing that tells us invertibility. If it doesn't reduce to I, not invertible. If it does reduce to I because there's a pivot in every column and it's square, invertible. So this reduces to I. So A is invertible. And remember, reduces to I, that's like saying square with a pivot in every column. Now, another way to think about this is we just saw that this system of equations has one solution. And we know that one solution is what occurs when A is invertible. If A is singular, not invertible, if A is singular, then there are either 0 solutions or infinite solutions. So A is also invertible because the system only has one solution. And that would be another way of thinking about it. Only has one solution. So those two things always go together. Those are our equivalent statements. Now our question 3 was asking us, what is the solution to AX is equal to 0? How many solutions does AX equal 0 have? Well, we just saw that A is invertible. We just saw that A reduces to I and has a pivot in every column. Therefore, AX equals 0 must have one solution. There's that pivot in every column. Now, just to kind of remind you, AX equals 0 is a homogeneous system. So AX equals 0. A is invertible, reduces to I, has a pivot in every column. All of those things mean the same thing. So A is invertible / reduces to I, has a pivot in every column. So therefore it has one solution. But because this is homogeneous, we actually know what that one solution is. It is the trivial solution. And the trivial solution is the origin, or the point 0, 0, 0. So in other words, what this is saying is, if instead of having my constants 1, 1, 1 there, I had 0, 0, 0, then the resulting 3 planes would only intersect at the origin. So in other words, we could say down here, the 3 planes, 3x plus y plus 2z is equal to 0, 2x plus z, 9z is equal to 0, and 4x plus 6y minus 3z is equal to 0, intersect only at the origin. And that's all. Bye, guys.